Hello, my name is Emir Bouzian. I am here with my colleague.
Hello, I am Ayub Ammar Boujlal. We are here to present our work for the project for the communication system course.
And as a start, we will just go over the general block diagram and what we will do in our simulation and experiment. As a start, as we will go through the video, we will talk about a general introduction, an explanation of the general flow and the general block diagram and what it's consisted of. Then we will go to the simulation where we will talk about the overall system and we will present our MATLAB code, which we will explain block by block. And at the end, we will do real implementation where we will show you the challenges that we encountered. And one of the challenges were the hardware challenges with the Adam Pluto, which at first we couldn't do the synchronization, which is the main problem. But we will show you how we figured it out and how we got the results. And at the end, we will show you some test results and we will play with the parameters, and that's it. That will be our video. So let's start by explaining the general block diagram. We can clearly see the blocks that we used in our simulation, and here we can see even the implementation on the hardware. So as a start, we will talk about the kinds of data sources that we can use. For the data sources, it's just, for our case, it's taking an image as data, where we load any image from the device. We can make it any other type of data, like video or sound or even raw data. Then we go to the data to blocks block, where we choose to divide, in our case, the image into blocks to avoid the complete loss of the data, where the image is resized to match the required number of blocks. Then go into the binary conversion, where we convert the image blocks into bit streams, zeros and ones. Next, we can see clearly here the modulation block, where the modulator takes the data bit stream and modulates it into M-FSK symbols, or multi-array frequency shift keying symbols. The modulation technique used is FSK, where the frequency of the carrier signal is shifted to represent the digital information.
Now, for the channel, we can see that we have two possible channels, which are the simulation channel and the real world channel for the implementation. For simulation, we chose to use an AWGN, which is additive white Gaussian noise generated in MATLAB using different noise power. And for the implementation purpose, we can't decide which channel to use because it is the real life channel, so we will face lots of different deviations, problems. Like if we take the effective channel, we can see like hardware impairments, we can see the Doppler effects, everything. So for that, we will discuss it later. Our work is divided again into two phases, which are the simulation and the implementation. As we can see, for the simulation, we use directly the demodulation, which takes our received signal and multiply it again with multiple frequencies depending on which modulation order we are using, and then we integrate over the symbol duration. Then we decide which symbol it is. For the implementation, there are several steps in addition to what we can see here, but we will discuss them later. Finally, the demodulated signal can be converted from decimal to binary based on which modulation we are choosing. And from that, we can see, we can check the block bit error rate, since we divided our data into blocks. After that, we can recover the data into their shape, like after collecting all the blocks, and we can check the bit error rate. We can check bit decisions, SNR, average power, and noise power. After this, we can finally convert our binary streams that are recovered to real data, which are in image format or any format we send. For the implementation part, we will see the challenges that we faced and how we fixed that, and how did we deal with these challenges, like which blocks did we use, why did we use them, and how.
So for the simulation part, I will show you directly on the MATLAB code how we managed to simulate the process of sending and receiving the image using FSK modulation. So let me first clear all. For this first part, we just gave the FSK parameters. This is just for the warnings that are given in the command window. I turned them off, so that it has no meaning. We can command this. For the modulation order, we used, as an example, 16. We gave the frequency deviation, the sampling rate, the duration of the signal in seconds, so the frequency that we have used, the center frequency. Then we went to the next block, which is data generation. As you can see, we said please choose any picture from your PC. It will work for any given picture, so you can choose any picture. For us, we just chose the picture that is given by MATLAB, the cameraman. So we can run the code as we are going. So we can run just the parameters. Then we have here for reading the image and given the size of the image. This is just to change the image from RGB into grayscale. If the image is already grayscale, then it will just stay grayscale. Then we resize the image in order to, so we can divide it by the number of blocks. We can run this as well. So up until here, we can see the image that we want to transmit. If we want, for this for loop is just the blocks that we are gonna send. So if I do this, then this is just the up into here. So this is sending the image. If we just continue it until the end, there is our received image, block by block, reaching. So this is what this for function is for. So for each block it will send, then when one block is sent, it will resend it again. So if we run the code as a whole, we can see it being transmitted in real time. Well, not in real time, but you can see the blocks filling in block by block.